Today we are going to design this model in idea statica. So this is like a two circular structure, and this is a half circular structure, uh, and then this is a rectangular plate, and this is a horizontal piping section. So let us try to design it in idea statica. So at first we have to open the idea statica software, go to the new, and then create a project. After that, the first thing we have to do is we should always add the member first, and then I go to this general tube, and the uh, diameter of this section and this section, let us put it first, and also this one is aligned at 7 degree with respect to this flat plate. So what I'm gonna do is I just put the dimension 914, thickness is 10 millimeter. Okay. After that we have to click on this perspective view, and then it will appear like this, and then click on this part in order to rotate like this, and also click on the same part in order to exit from that portion, so it will be easy with this one. So this is M1, and then gamma p is 7 degree, and let us try to do offset from Ex minus 100. So now it looks like this. Now we again have to add another member, M2, and it has the rotation of minus 7 degree. I can press it 0, and then offset EZ, so the distance between these two is uh, minus 1044, and it looks like this. Now again I have to add another member, this one. So there is a reason why I am not adding these two member, because if you add these two member and try to cut with this plate, cut member can only be used once, so it cannot be cut into two places, like a cut into this time, this part and this part. So at first let us add the member M3, go to this plus, and our M3 has a dimension of 457 and thickness 10 millimeter. Okay, and then there is no angle, beta direction 180 degree, and then offset EZ I am gonna do 2000. Sorry, it's gonna be on X direction, so offset EX is 2000 here, and it needs to align in between these two members, so offset EZ is gonna be minus 547 like this, and it is aligned in the center of the two member. And then after that I am gonna add another member called M4, which is this horizontal member. So again I'll go to member, M4, go here, it has the similar diameter 914 and thickness is 12 millimeter. Okay, and then let us try to change this beta direction minus 90, and then Ex 1000, EY I am gonna do minus 630, and then is it I'm gonna do minus 487. So it looks somewhat like this, and then I'm gonna try to change the offset 0. So if I try to do minus 1000, so it looks somewhat like this. So now let me turn off the memory info for now, and let us try to add the stiffening plates like these two plates. Just remember, in any member or section, the cut operation can only be applied at only one place. So let us first add a stiffening plate. Go to operation, go to this stiffening plate, and then modify the thickness. Mine is 30 millimeter. So you can get the dimension of all of these things depending upon your design. And then I will try to rotate it by 90 degree. So it looks somewhat like this. Yeah. And then if I go to, because here it should be rounded, so for that I just go to editor section and then go to rounding all corners and do the value to 210. Apply. Okay, so rounding has been applied, as we can see. After that, mm, let us add another plate here on the top. So just follow the sequence. If you don't follow the sequence, then it's going to be difficult. You will not be able to assign all the operations properly. So what I'm going to do is I'm just going to copy sp2. Thickness of sp2 is 15 and its width is 600 by 1600. 600, okay. And yux I'm gonna do 1225, sorry, minus 1225, and now it looks like this. So why I did 1225 is like distance between this member and this member is 1225, that's why. And now I'm gonna keep this yum3 member a bit down, 2000 to 1025, and it looks somewhat like this. So now our member has been added. Now we have to do cut operations. We have to cut this member M1 and M2 by SP1 and this member by this. So let us go to operation and we use the cut operation. So for cut 1, what we have to do is member M1 cut by SP1 and then just adjust your weld size. And now we can see our member has been cut. Once again, just copy, and then now it's member M2 that should be cut by SP1. So it is cut, it is cut. Now again we have to copy this and then member M3 cut by SP2. Now weld has been applied simultaneously. And if you also want to weld in the inner side, here it is weld only on the outer side. If you want to weld on the inner side, just go here and then do double fillet weld. It has been applied on cut 3. So let us check. Sorry, on the both side. Uh, Double fillet weld. So now we can see our weld has been applied on the both side. So from here we can just adjust the weld parameter. Now we are welding only on outside, and then after that we have to put these two members on the both side. So for that we are not going to use the member, we are going to use operation, and then we will use the stiffening member. Always remember to do this, because if you don't do this then it's going to be difficult to do cut operations. So this is the most important part. So stiffening member 1, and it has the same dimensions. So length, let me do 1300, and it looks like this. Offset EZ is 100, because this member is a bit outside as compared to this member. From here this member is a bit outside as compared to this member, so I'm gonna offset it by 100 millimeter, and then gamma pitch 7 degree, because it is also inclined 7 degree. And then after that I'm gonna copy this one, and then length maybe I can put the same, and offset EZ I'm gonna offset it into this side. So let me do it offset by minus 1100, and then minus 7 degree. Now it looks like this, but here in order to perform the cut operation, this member should touch this member completely. So maybe if I increase this by 300, now it has been done perfectly. After that, let us copy the cut operation. Cut for member SM1, cut of part begin and cut by plate SP. Here we can see. So this is the cut of part beginning. Yeah, that's why the beginning of the portion has been cut. So if we just try to copy this, cut 5, let us do cut by SP1, and then here if we try to do cut of part end, then the beginning and end portion has been cut successfully, like this. And similarly, let us do cut operation on SM2. So just copy cut 4 and copy cut 5. Let us go to cut 6 and just make SM1 to SM2. Similarly here, let us just change SM1 to SM2. Now our cut operation has been done successfully. So after that, one of the most important part here, we can see this portion should be cut, and there is a rectangular plate like this, and this is just a half tubular section. So what does it mean is like we need to cut this SM2 and SM1 into half. By some rectangular thing. So what I tried was like I tried to go to operation and then try to do it by knots, but it was completely impossible. So what we can do is we can use the operation called negative volume. This one, negative volume. So what it does is it just create a negative volume. So let us try the negative volume of let us try this 1200, and let us try this 1260. Okay, okay, now it looks like this. Now let us try to change the length up to 1320. If we do that, then the height will increase, yeah, like this. And then after that, what we can do is uh, we need to offset towards this side. So it looks somewhat like this. And let us do minus 500, and it will come towards this side. So it should look somewhat like this. And then after that, we need to perform the cut operation. So we need to cut this portion by negative volume. So just go to operation, cut operation. Now look, cut it, member SM1, cut by negative volume. This is the sign of negative volume. No, this is sign of working plane. Just go here, click here, negative volume. Look, it's gone. So this is the way how we can cut or make our section into desired shape. And then again we can go to cut it, copy, just do SM2. Now we can see our member has been cut successfully like this. And then if we turn on this one, so it looks somewhat like this, yeah. And then now we have to add a rectangular plate here. So for that I'm going to go to the operation. Let us add a stiffening plate third, and let us change the dimension and thickness of the member. 16, 900, 600, 600, 600, and let us try to change the orientation. Minus 440. You can just play along it in order to make it into the correct position. So that I am doing the same. 450, Z is minus 500, and then if I try to rotate it into 90 degree, so it will look somewhat like this on this side. I know the video is long, but it is important, that's why. Now we need to cut this plate by this plate. So what we have to do is, if we want to cut the plate, then we have to use the operation called this one, P cut 1 and P cut 2. So now we are under the P cut 1. So we are going to cut the modified item SP3. So this is SP3 and cut by SP1. This is SP1, and then we need here remaining part. So now we can see only the bottom portion, but it should be like this. Here a cut operation has been performed, and then there is a weld, contact weld, or I can do butt weld. There is a weld somewhere here. So if we try to do this, then we can see there is a weld, yeah, here. So this is how we can see the weld is being done. Again we have to perform another cut operation. Now it's gonna be by SP2, and then remaining part plus here and butt weld. So now it looks somewhat like this. Now again we have to add another cut operation, and in this time we are going to cut sp3 by member 4, because there needs to be hole here also. And then cutting method surface. Now we can see the cutting operation has been done successfully, and we are going to use double fillet weld with 3 millimeter. So weld also has been applied. So we have to do the similar thing on the next side, and then after that we can add these rounding plates, so it is not so hard. So we can do it by some practice. And the video is a bit long, so I want to end my video, but I hope this one was a bit challenging task for me, but I try to do it successfully, so maybe you can also do it. And if there is any question, just comment and I will try to help you.